Hello and welcome back to Math 1324. We are still in Chapter 4, Systems of Linear Equations and Matrices. And today we're going to talk about the inverse of a square matrix. The first thing we're going to discuss is the identity matrix for multiplication. And the definition, the identity element for multiplication. So the identity element for multiplication for the set of all square matrices of order n, and remember that a square matrix of order n has n rows and n columns. So the identity element is the square matrix of order n denoted by I, kind of looks like a slanted one, but it's denoted by I, and it has ones along the principal diagonal. So down here, these are all ones down the principal diagonal. And zeros elsewhere. So I want you to go multiply these matrices. If you multiply the matrix 1, -5, 8, 2 by the matrix, the identity matrix, what do you get? Since we're not doing this by hand, I'm going to do one by hand, and then I'm not going to do any others by hand. I would do 1 times 1 plus -5 times 0. That's my first element. Then I'm going to do 1 times 0 plus -5 times 1. Then I'm going to do 8 times 1 plus 2 times 0. And 8 times 0 plus 2 times 1. So my matrix would be 1, -5, 8, 2. Look, if you multiply this 2 by 2 matrix by the identity matrix, you get 1, -5, 8, 2 as the answer. Same thing on this one, and for time's sake, I'm going to show you it would be 1 plus 0, and then -5 plus 0, and then 0 plus 8, and then 0 plus 2. Okay, a note down here at the bottom, it says if M is a square matrix of order n, and I is the identity matrix of order n, then when you do matrix multiplication I times M or M times I, you get back M. All right, if M is not a square matrix, it is still possible to multiply M on the left and on the right by an identity matrix, but not with the same size identity matrix. We will restrict the attention to our attention to square matrices, and that should be on, by the way. We're going to restrict our attention to just square matrices. Now let's go look at the inverse of a square matrix. First, let's explore what are real number solutions to x squared equals 1. So when you're dealing with real numbers and you want to take the square root of both sides, do you remember you have to put a plus or minus out front? So the solution would be x equals plus or minus 1. Okay, for a matrix, let's go show that if we have the matrix 0, 1, 1, 0, and we square it, that we get the identity matrix. So we want to multiply 0, 1, 1, 0 times 0, 1, 1, 0. Doing that matrix multiplication, row times column, I would get 0 plus 1. Then I want to do row times column. I would get 0 plus 0. Then I want to do this row times that column, so 0 plus 0. And last but not least, I want to do this row and that column, 1 plus 0. is 1. So we just showed that if we took that matrix A and multiplied by itself, we came out with the 2 by 2 identity matrix. All right. Now let's go show that if B is 0, -1, -1, 0, it too is the identity matrix. So 0, -1, -1, 0 times 0, -1, -1, 0. We would get 0 plus 1, and then 0 plus 0, and then 0 plus 0, and last but not least, 1 plus 0. So again, we get the 2 by 2 identity matrix. All right, let's go talk about some definitions. If R is if R is an arbitrary real number, then its additive inverse is the solution X to the equation R plus X equals 0. For example, what's the additive inverse of the number 3? Well, the additive inverse is -3 because 3 plus -3 is 0. So -3 is the additive inverse of 3. Okay, what about matrices? If M is an arbitrary M by N matrix, then we say M has an additive inverse, and we're going to denote it by -M, whose elements are just the additive inverse of the elements of M. So over here on the side, if my matrix M was 1, 2, 4, -5, then my additive inverse would be -1, -2, -4, +5. Okay, the multiplicative inverse. The multiplicative inverse of an arbitrary real number R is the solution X to the equation R times X equals 1. Okay, an example. The multiplicative inverse of 3 is 1/3, because you can do 3 times 1/3 and get 1. One more time. 1/3 is the multiplicative inverse of 3, because 3 times 1/3 is 1. All right, every real number except for 0 has a multiplicative inverse. Now let's go look at matrices. Let M be a square matrix of order n, and I be the identity matrix of order n, if there exists a matrix, and we're going to denote it by M inverse, such that M inverse times M equals M times M inverse equals the identity matrix, then we say M inverse is the multiplicative inverse of M. So M inverse is the multiplicative inverse of M, or we just say that it's the inverse of M. If no such matrix exists, then M is called a singular matrix. If the matrix M does not have a inverse, then M is called a singular matrix. Okay, how do we find an inverse of a square matrix? we're going to write the augmented matrix M with the identity matrix on the right. And we're going to use row operations to transform the MI into IM inverse. And then we need to verify that M inverse times M is 1. Okay, if zeros are obtained in one or more rows to the left of the vertical line, then the inverse does not exist, and we say that M is a singular matrix. Okay, we want to go find the inverse of this 2 by 2 matrix. So we're going to do 2, -6, 1, -2, and then the identity matrix 1, 0, 0, 1. And I want to get this be the identity matrix by doing row operations. The first thing I need to do is get a 1 up here, and I'm going to do that by doing a row swap. Swap row 1 and row 2. And if I do, I get 1, -2, 0, 1, 2, -6, 1, 0. Okay, next thing I'm going to do, I need to get a 0 here. I'm going to do that by saying -2 times row 1 added to row 2 and make it my new row 2. So what does that look like? -2 times this row. -2, 4, 0, -2. And I want to add it to 2, -6, 1, 0. So I will get 0, -2, 1, -2. So here comes my matrix. Leave row 1 alone. 1, -2, 0, 1. And my new row 2 is 0, -2, 1, -2. All right. I got the 1, I got the 0. I need to make this one a 1. And I'm going to do that by multiplying row 2 by -1/2 and make that my new row 2. Row 1 stays the same, but my new row 2 becomes 0, 1, -1/2, 1. One more step. I need to get a 0 here. I'm going to do that by saying 2 times row 2 plus row 1, make it my new row 1. So 2 times row 2 gives me 0, 2, -1, 2. I'm adding that to row 1, 1, -2, 0, 1. And I get 1, 0, -1, 3. So my matrix is, I leave row 2 alone, and my row 1 is 1, 0, -1, 3. So here is my M inverse. M inverse is -1, 3, 1, -1/2. Now, I'm going to jump down to the bottom of the page and show you the shortcut. The shortcut to find the inverse of a 2 by 2 matrix, you're going to swap A and D. You're going to put a negative sign in front of B and C, and then you're going to divide every one of those terms by AD minus BC. So let's go do the shortcut to find the inverse of this one. Oh, wait a minute, we can't. What is AD minus BC? That would be 3 times 2 minus 6 times 1. That would be 0. So when we try to do the shortcut to find the inverse of matrix 2, we can't. M inverse does not exist because M is a singular matrix. You have to divide all of those by that AD minus BC, this product minus that product. You can't divide by 0. So that matrix does not have an inverse. Okay, for time's sake, let's go do this one on the calculator. All right, remember how to get to matrices. Second matrix, I want to edit, hit enter. This is a 3 by 3 matrix, and the matrix is 1, 0, 1, -3, 1, -2, 0, 0, 1. Okay, if I go back to my home screen and say second matrix and hit enter, what does matrix A look like? Okay, good. Now I want to do second matrix A inverse. See the button that's lit up red? That's the inverse. Hit enter. That's it. That's A inverse. The inverse matrix is 1, 0, -1, 3, 1, -1, 0, 0, 1. Now, if I let this be M, if I do M times M inverse, what would I get? On my calculator, I'm going to do A times A inverse. I better get the identity matrix. And I do. So M times M inverse equals the identity matrix. Okay, let's go look at an application of matrices and their inverses. One area is in cryptography. So matrix inverses can provide a simple and effective procedure for encoding and decoding messages. So you're going to assign the numbers 1 through 26 to the letters of the alphabet, and you're going to assign a 0 to a blank to provide for a space between words. So a more sophisticated code could include both capital and lowercase letters and even punctuation symbols. So here we go. A blank is assigned to a 0, and then the letters A through Z are assigned the numbers 1 through 26. So here's the process. The message secret code corresponds to the following sequence. Let's go check it out. So S, let's see, S is a 19, E is a 5, C is a 3, R is an 18, we said E was a 5, and then T is a 20. Then we want a space between words, so we're going to put the 0. And then C is a 3, O is 15, D is 4, and E is 5. Okay, any matrix whose elements are positive integers and whose inverse exists can be used as what we call an encoding matrix. For example, to use this matrix, matrix A, 4, 3, 1, 1, to encode the message, first divide the numbers in the sequence into groups of 2 and use these groups as columns of a matrix B with 2 rows. So up here, we're going to do them in groups of 2. And we're going to turn those numbers into columns. And notice that we only have one number, so we're going to do a placeholder with a 0. So we had 19.5 as the first column, 318 is the second column, 520 is the third column, 0, 3, 15, 4, 5, and then since we ran out of things, we've got to put a 0 there. You're going to multiply this matrix on the left by A. So here was what we were given A. So we're going to do A times our matrix with our code. And this is what we're looking for. So then we're going to say that the coded message, okay, we go down the columns, 9124, 6621, 8025, 93, 7219, 25. Okay, so that is our coded message. And that message can be decoded by putting it back into matrix form and multiplying on the left by the decoding matrix. A inverse. So if you know matrix A, you can easily find A inverse and then decode the message. So here we go. This message was encoded with this matrix. We want to decode the message. So the first thing we need to do is find A inverse. I'm going to go edit my matrix A. It's a 3 by 3, and the matrix is 1, 1, 1, 2, 1, 2, 2, 3, 1. Second quit. My matrix A inverse is that matrix, -5, 2, 1. Two, -1, 0. 4, -1, -1. Okay, so if I go do on my calculator that matrix multiplied by, okay, let's put our code in rows of 3, or columns of 3. So I have 46, 84, 85, 28, 47, 46, 4, 5, 10, 30, 48, 72, 29, 57, 38, 38, 57, 95. I want to go do that matrix operation or multiplication on my calculator. So here goes. I'm going to leave that one alone. Then I'm going to go in here and do matrix B. So edit matrix B. That's going to be 3 rows by 6 columns. So 3 by 6. And here we go. 46, 28, 4. 30, 29, 38. 84, 47, 5. 48, 57, 57. 85, 46, 10. 72, 38, 95. Okay, that looks right. 46, 84, 85, 28, 47, 46, 4, 5, 10, 30, 48, 72, 29, 57, 38, 38, 57, 95. Perfect. All right. We want to go do matrix A inverse times matrix B. Okay, there's our decoded message. And we're going to read it straight down the columns. 23, 8, 15. 0, 9, 19. 0, 3, 1. 18, 12, 0. 7, 1, 21. 19, 19, 0. All right, remember that everywhere we have a 0, that's a space. So that's a new word. Right, what number or what letter did 23, 8, 15? Let's go see. 23, 8, 15. 23, 8, 15. So WHO is the first word. 9, 19. So 9, 19. Who is 3, 1, 18, 12. 3, 1, 18, 12. C-A-R-L. C-A-R-L. 7, 1, 21. 7, 1, 21. G-A-U. And then 19 twice. 19 is S. Who is Carl Gauss? Is the message. And that's it. That's all I have for this section. Now it's time to go practice and do the homework. Till next time. Bye.